Okay, so what we're going to do today is we are going to be talking um, about essentially naming hydrocarbons that have a parent chain that end in "ene" or "ine." Okay, so essentially whether they have a double or a triple bond in the parent chain. Now, the things that we need to just kind of remember is really the rules for naming these particular compounds are the same. The only difference is that the double or the triple bond needs to be in the parent chain. So double or triple bond, it must be in the parent chain. It also must be in the lowest spot. Okay, and the only other thing that we need to do is we need to make sure that we must name it. So we need to name where the bond is. Okay, so what we're going to do in order to understand this concept is we are going to actually be making sure that we're going to be just doing some examples for this particular thing. So where we're going to get our examples from is we're going to get our examples from page 129. So page 129 in the textbook, okay? And we're going to do here question 28A in order to help us out. So here we go. So 28A has really something quite simple. So it's got a compound that looks like this. Sorry, I kind of ran out of room there. So this is what the compound looks like. Note here that I've got a double bond. Okay, so what I need to do is I need to number this particular hydrocarbon such that that double bond is in the lowest spot. So let's try 1, 2, 3, 4, 5, 6. So right now it's after the third carbon, but if I also numbered it this way, it would also be after the third carbon, so that really doesn't matter. So I have 6 carbons, which means that this is hex for 6, ene now, meaning that I have a double bond, and I just put in front of there, bam, it is 3-hexene because 3 is where that double bond occurs, or occurs after the third carbon. Okay, so now we're going to try something a little bit more complex with B here. So and right here, I've got, there we go. Okay, so this is 28B, and the things that we need to kind of make note of is right here, that is a double bond. So the double bond needs to be included in the parent chain. So now again, it doesn't matter whether I make my parent chain in this direction or if I'm going to make my parent chain like that. What really matters is the fact that that double bond is in the parent chain. Okay, so I could not, for instance, make my parent chain kind of look like this in this particular instance because I need to make sure that that double bond is there. So what I'm going to do is I'm just going to, for fun, select this particular parent chain, just again to kind of throw the point home that it's not always going to be the straight chain. Okay, we may have a curve in there. So I just want to always kind of bring that to the forefront. So in this particular thing, now I've got a parent chain, I've got a branch, so I need to name my parent chain first. Okay, my parent chain has 1, 2, 3, 4, 5 carbons. So because it has 5 carbons, it is pentene. Okay, that double bond is after carbon 2, so this is 2-pentene. Now, it has a branch on it. Okay, the branch has 2 carbons, so branch, 2 carbons. So ethyl, it's an ethyl branch, and that happens to be on the 3rd carbon. So this is 3-ethyl 2-pentene. So this is kind of getting to be repetitious, and it's exactly kind of how we would expect it to be, given kind of our previous knowledge on how to name alkanes or branched alkanes. So again, we're on page 129, number 28. And we're going to be looking now at C. So in this case here, I have something like this, where I have a branch here, and I have a branch here. Okay, so again, parent chain needs to include the double bond. Awesome, mine does. Okay, ene, double bond. Okay, I want to make sure that double bond is in the lowest possible spot. And that's really all that matters in when I'm numbering. So in this case, I have 5 carbons, so it's pent for pentene. 2, because that's where the double bond is. It's after the 2nd carbon. Now I have 2 branches, both being single carbons, so they're both methyl branches. I have 2 of them, so I have dimethyl. I have 1 on the 2 and 1 on the 3. So 2,3-dimethyl 2-pentene is the name of this particular structure. So let's try just something a little bit harder here. We're looking at E. Okay, and this will be our last example together. Oh, I forgot this one here. And then right here, got this. All right, sorry that took so long to draw out, but we've got a lot going on there. So right away here, I have a triple bond. Awesome. Now I'm going to make sure that I get all of the longest chain in there. So like I've been kind of trying to drive home here, make sure that you're kind of open to curved chains, okay? So in this case, it's definitely a curved chain in order to get the largest amount of carbons in a single chain in there. So remember, what I have to do is I need to number these carbons such that the triple bond is in the lowest spot. So 8, so oct. Okay, I've got a triple bond, so now it's octyne. Okay, and that is after the 2nd carbon. So I have 2-octyne here. Now I have 2 branches. I have a methyl and an ethyl. Now I'm going to ask myself alphabetically which one comes first, and that would be eth. So what I'm going to just do here is I'm going to write my ethyl branch in here. So ethyl, and then I have a methyl branch. Okay, the methyl branch is on carbon 5, and the ethyl branch is on carbon 4. So this particular compound is 4-ethyl, 5-methyl, 2-octyne. Okay, so here we go. What we're going to do now is we're going to look about going from name to structure. What we're going to do is, again, on page 129, but now we're going to be talking about question number 29. And we're going to do B as an example where we have 2-pentine. Okay, so just to break this down again for us, so ine, this means a triple bond. Okay, pent, 5 carbons. And where is that triple bond? Well, it is on, or after, I guess I should say, not on, but after the second carbon. Okay, so I have 5 carbons, 1, 2, 3, 4, 5. After the second carbon, 1, 2, after the second carbon, I have a triple bond. I have all single bonds in there. Now I need to make sure that I am covered with my hydrogens. Well, this guy here has 4 bonds. This one here has 4 bonds. So I have double bond here, or with the 2 bonds, so then I've filled in my end there. Okay, sorry, I had to pause the problem there. So what we were doing is we were just finishing in the hydrocarbon, or sorry, the hydrogens here, so that we can end up answering or putting the entire uh, actual chemical formula in. So this becomes CH3, carbon, triple bond, carbon, CH2, CH3, and that is kind of the final answer for that particular question here, which was 29B. So just to do one more problem, making it a little bit more difficult here, is we're going to do 29D. 29D reads 2,5 dimethyl 3-heptene. So just to decode this again a little bit. So here we go. We've got "-ine", meaning a triple bond. Okay. "Hept" means 7 carbons. Okay. Where is that triple bond? Well, the triple bond is after the third carbon. I've got a few branches here. Okay, so "ol" meaning a branch. "Meth" means 1 carbon. "Di" meaning I have 2 of these branches. So where are those 2 branches? Well, they are on carbons 2 and 5. Okay, so what I'm going to do here is I'm going to start out by making my 7 carbons. After the third carbon, so 1, 2, 3, I have a triple bond. Everything else has some singles there. Okay, now for my branches, I have a methyl on branch, or on carbon 2, and then 1, 2, 3, 4, 5, 1 on carbon 5. Then I'm just going to put these little red marks here to fill in the carbons, so that they all have 4 bonds, where the reds represent the hydrogens that are missing from here. So then when I write the condensed structural formula here, I have CH3, CH3, bound to a carbon that is triple bound to another carbon, carbon hydrogen, CH3, and then I have CH2 and CH3. So that there is the correct structural formula for 2,5-dimethyl-3-heptene. All right, so with that, that is kind of a quick little lesson here for naming branched alkenes and alkynes. If you have any other questions about this, be sure to make sure that you have an email. It's really the same as naming any other compound. The only difference, just the same as naming an alkene. The only difference now is that we have this "-ine" and "-ine", and then we have to identify where the triple bond happens to be. All right, thank you very much.